Hi guys, today we're going to be looking at a question on photoelectric effect. Question 11. The threshold frequency of calcium, I might be saying that wrong, that is my bad, and potassium metals are given in the table below. Question 11.1. Define the term work function in words. So work function of a metal is the minimum energy needed to eject an electron from the metal surface. Question 11.2. Which one of the two metals in the table has a higher work function? Give a reason for your answer by referring to the information in the table. So as we can see in the table, potassium has a higher threshold frequency. Therefore, it will have a higher work function as the photons that hit the metal surface need to have a high frequency in order to eject an electron. This means that they have a higher work function. The simplified diagrams below show two circuits, A and B, containing photocells. The photocells in circuit A contain a calcium metal plate, while the photocell in circuit B contains a potassium metal plate. Ultraviolet light with the same intensity and wavelength of 5.5 times 10 to the negative 7 is incident on the metal plate in each of the photocells, and the ammeter in circuit A registers a current. Question 11.3. By means of calculation, determine whether the ammeter on circuit B will also register a current. To do this, we can calculate the frequency of the light that shines on the circuit. And if this frequency is higher or equal to the threshold frequency, then it will also register a current. So to do that, we can say that C is equal to F, which is frequency, times lambda. We then know C is a constant, so 3 times 10 to the power 8 is equal to frequency, and then our wavelength. And if we rearrange and plug all of this into the calculator, we should get 5,545 times 10 to the 14 Hertz. This frequency that we have calculated, however, is less than the frequency, or the threshold frequency, of potassium. Therefore, no reading will show on the ammeter. Question 11.4. Calculate the maximum kinetic energy of an ejected electron in circuit A. So, to calculate this, we can say that E, the energy, is equal to the work function plus EK max, which is what we are trying to calculate. We then can decompose this E into its parts, being H C over lambda. We can decompose work function into H C over threshold wavelength, and then EK max. Now we can just plug in all our values, H being a constant, C also being a constant, and when we rearrange, we should get that EK max is equal to 2,55 times 10 to the negative 20 joules. Question 11.5. How will the maximum kinetic energy of an ejected electron, calculated in question 11.4, change when the intensity of the incident light increases? As we know, if the intensity of the light increases, it does not change the energy of the electron ejected, as intensity just is the amount of light that is incident on the metal, not the energy of the light. Therefore, we would say that it remains the same. And that's all for this video. Thank you.